AWS has three options for storing things. Now the first is EBS, your elastic block storage, and this is going to be your hard drive to your EC2 instance. 9 times out of 10, when you're building an EC2 instance, you're going to have an elastic block storage attached to it. And this means that even if your EC2 instance was to fail for some reason, any files stored within your elastic block storage would remain, because that's going to be a separate unit attached to the EC2 instance. Now the second type is called EFS, meaning elastic file storage. And this is like your elastic block storage, but it's shared with multiple EC2 instances. So if you had multiple instances running in parallel, using EFS, you could share files between them really easily. So your EBS is the storage that would be used to install your operating system and other instance specific data, and your EFS would be the file system that's shared across your network. And that brings us on to S3 storage. This is Amazon's second most widely used service after EC2 because it's so versatile. So the S3 service, also called the simple storage device and the object storage, allows you to store objects inside containers called buckets. And an object could be anything. So any kind of file, video, image, whatever you want. Now, objects in S3 are known to be very durable, so the chances of losing your data once it's stored inside a bucket is small enough to be considered impossible. Now, things stored in S3 buckets are generally going to be for internal use. So if you wanted to share things with your users, the best practice would be, instead of exposing your S3 buckets directly, you would upload that data to CloudFront and then have your user access your data from there. So this would reduce the latency with accessing that data for your user, and for you it would improve your security because the user won't be directly accessing your data storage. Now by default, data in S3 is accessible only to the person that created it, and S3 is a serverless service, so you're not going to be responsible for any of the configuration behind the scenes. Now pricing in S3 is where it gets a little bit complicated because there's lots of options depending on how you want to store your data. So the first and most expensive pricing tier is S3 Standard, and this is the default and most popular storage class for frequently accessed data. The next step down is Standard IA, or infrequently accessed. This is very similar to S3 Standard, but it has a lower storage cost and a higher retrieval cost. So every time you're pulling data from it, you're going to pay a higher cost for it. This might end up cheaper if you're storing a lot of data in S3, but you're not accessing it often. Now the next step below that is your Standard One Zone IA. Now in Standard and Standard IA storage classes, your data is going to be replicated in every single availability zone in your region. But in Standard One Zone IA, your data will only be stored in one availability zone. What this means in practice is, if one availability zone were to go down for some reason, let's say there was a fire, then you might lose your data. But if your data was replicated in lots of availability zones, then you still have an active backup. The next step down is S3 Glacier, and this is very low cost storage for data archiving. So once you've stored an object in S3 Glacier and you want to retrieve that object, it can take between a few minutes to a few hours to get your object back. So this is for items you don't need to access instantly. And the last and lowest cost storage option is S3 Glacier Deep Archive. And this is like S3 Glacier, except with this one, it can take up to 12 hours to retrieve an object. As for why it's taking so long, you can think of it like an algorithm packaging up your data to reduce its file size. And then when you want to retrieve that data back again, it has to be unpackaged before you can access it. And if you're not sure which kind of storage class you need, there is something called S3 Intelligent Tiering, which monitors how often you're accessing your data and then chooses your storage class for you. But this does have a monthly monitoring fee, so if you already know which storage class you need, then it's best to do it yourself. Now let's talk about databases in AWS. So a relational database is a structured table like an Excel spreadsheet. So you're going to have the same columns of data for every single item in your database. So this is the kind of database like Amazon would use for their products page. So every single product is going to need the price, the size, and the same categories of data filled out. And the alternative is your non-relational database. So this is where the structure doesn't matter, but the data itself does. And a large use case is for things like big data processing. So if you were gathering opinions on something, you'd have tweets, Facebook posts, articles, etc. And every single one of those is going to have a different structure. Now for relational databases, Amazon provides something called RDS, or Relational Database Service. Now this lets you operate and scale a relational database in the AWS cloud, and it automates a bunch of the time-consuming tasks for you, like updates, backups, replication, failover. It does all of that. However, RDS won't auto-scale for you. You'll have to manage scaling yourself. You'll also need to choose an RDS database engine. So examples include AWS Aurora, PostgreSQL, SQL. Now Aurora is the AWS solution for a database engine. So what they did is they took MySQL and PostgreSQL, they optimized them in their own solution for AWS Cloud. What that means is using Aurora for your database engine, you're going to get 3 times faster performance than using MySQL, and it's going to be cheaper because you're not going to be paying Microsoft or Oracle for licenses to use their database engine. So as for pricing, you'll be paying for RDS as long as your server is running, whether or not you're actually running any queries on it. And an alternative is installing your database engine directly onto an EC2 instance. But if you take that path, you're going to be managing updates, replication, and all of the rest by yourself. So RDS just makes everything simple. And if you want to make things even simpler, you can just use a serverless database, like Dynamo. Now DynamoDB is Amazon's non-relational serverless database. So serverless meaning Amazon handles everything for you. All you're concerned with is that you have a database engine, you can store data to it and retrieve data from it. Now with Dynamo, you're only going to be paying while you're actually querying the database, and it automatically scales to adjust for capacity. So it's been designed to handle up to 10 trillion requests every single day. So it's basically good for any use case. And as for how non-relational databases work, DynamoDB is a key value database. So every single item of data inside your database is going to have a key, which is going to be used to retrieve that data when you need it. That's all for this one. Next video, we're looking at security. See you there.